All right, guys, today is the 18th of July, and here are the solutions to the do now. Okay, you should not be watching the solutions until you've actually attempted to do all three. We are in summer school lesson 9, similarity. And the first question is a construction, and it's actually asking to construct a line perpendicular to AB through point P. So many of us forget how to do constructions. It's kind of like one of those out of sight, out of mind sort of topics, and you are going to want to remember how to do most of the constructions. So we'll have a day where we just go through constructions, okay? So this one is very simple. We want to construct a line that's going to be perpendicular or will form a 90-degree angle with this segment right here. And so the way to do that is literally take your compass point, or your focus point, as it's also called, and extend it so that it ends up somewhere underneath this line, okay? When you do that, that setting that you're going to have, you're going to hold on to that setting. You're going to keep it. You're not going to change it. So my focus point is on the point P, and then again, I extended my pencil so that it was underneath the line, and then I just made an arc, okay? Keeping that same setting, I'm just going to make another arc, okay? So I'm literally just making two arcs with the same setting, okay? So then, from there, I'm going to label both of those points, and we can go with C and D, and you're going to, again, that setting has to stay the same. You're going to take that focus point, put it on that point here, and then draw an arc. Keep the setting the same, draw another arc. Okay? So then you are going to end up with this situation down here. The key here is just to keep the setting the same. Label that E, and then using a straight edge, which I have to actually get up and get. Using a straight edge, you are just going to connect these, and you've got your perpendicular line. Okay. Now for this construction, you want to indicate that the lines are perpendicular by drawing in that box. And you're finished. So if you need a little bit more guidance on this, you can always go to Math Open Reference, or you can just rewatch this video a couple times, okay? Next one, it says in the diagram below of circle O, the circle is always named by its center, the diameter AB and radii OC and OD are drawn. The length of AB is 12, and the measure of COD is 20 degrees. If arc AC is congruent to arc BD, find the area of sector BOD in terms of pi. So hopefully you did go through your textbooks or blue books to refer to. But if you didn't, we'll get to that now. And what I do encourage you to do, because you're going to have do-nows that, you're not going to necessarily recall, you are going to have to use some type of reference material, okay? So, important information here. It says in the diagram below that AB is the diameter. What does that mean? Well, it means that it splits the circle in half and into two semicircles, okay? So we have semicircle AB, which is 180 degrees as an arc, and semicircle AB as well, which is 180 degrees as an arc. Okay. Sorry, my computer just acted a little wonky. All right, it says the length of AB is 12, so the diameter is 12, which would mean that the radii are 6, right? So this is a radius from here to here, that's 6. That's also 6. This is also a radius because it's drawn from the center. All of these are 6, okay? And the measure of COD is 20 degrees, okay? And then we're told that these two arcs are congruent. Well, I know that this whole thing is 80 degrees. okay? So that means, I'm sorry, this whole thing is 180 minus 20 would be 160. And if I divide that in two, that would make this 80 degrees and this arc 80 degrees. So again, 80 plus 80 is 160 plus 20 is 180, meaning that this is a full semicircle, as this is as well. Find the area of sector BOD, so this sector here, in terms of pi. So sector area is found by taking, so the area of a sector is found by taking the area of a circle, which is pi r squared, and multiplying it by theta over 360. So theta would be the section of the circle that we're looking for. So this is the section, this is the sector, it's 80 degrees, this arc is 80 degrees, and this would be considered a central angle. Arcs and central angles have the same measurement, okay? So we're basically doing the sector area is equal to pi times 6, the radius is 6, times 80, the area of the, or rather the theta is the central angle, okay? And so the central angle, or the measure of degrees of this sector, is 80 degrees because its arc is 80 degrees. And we found the arc, once again, by using the information to calculate the measures, okay? So it's going to be 80 over 360. All you would need to do is put those values into your calculator and then multiply. Take a second to do that. Pause, and you'll see the solution in the next video.